Digital sovereignty enabling architecture. Digital sovereignty enabling architecture. Digital sovereignty enabling architecture.
Digital sovereignty enabling architecture. Right, that's what we will be walking through here in this diagram. I will explain all these items here in some sense. So here we start with unspecified intent, which basically means that when a user uh, opens an application, opens a website where an external uh, service provider, some company or non-profit or whatever, gets their code, gets execution context in a sandbox or full system access or whatever, um, it, it it basically uh, leads to uncontrolled exposure. So unspecified intent on what exactly it is the user wants leads to uncontrolled exposure to a service provider. And well, to combat this issue, we would like to have what I call actor software. So actor means uh, any device connected to a shared network. So it's one uh, actor, one actor in a network of devices, and that actor software has access to offline storage, and when there is a network available, it can also connect to the service provider's base stations. And both offline storage and base stations shouldn't have any plain text data. So uh, to find data from offline storage, even everything should be keyed and or indexed by some opaque ID, right? Something that has no semantic meaning. It's just a set of characters. So you find uh, some random set of characters with another set of characters, as only ciphertext should be stored in the offline storage and in the base station. So actor software communicates with offline storage and base station within service boundary, right? Within the scope the service provider has access to. And when when uh, this there's not yet a complete specification, but like if it is and will be specification compliant actor software, when when uh, there's unspecified intent and uncontrolled exposure, which to clarify means that when you when you when you load into, let's say you load into YouTube, right? First of all, you there really isn't any reason why YouTube should have access to your like, let's say, view history. I mean, you want to have access to your view history, and that's fine. But there's no reason why YouTube should have access to it. And even especially without you being active on the platform. So if if you are offline, they definitely shouldn't be able to have access to it, but they can. And let's say you loaded into their service, they wouldn't have access, but you loaded, opened up YouTube. It could be by accident or it could be whatever, but it's not like you, by opening YouTube, you want to share your viewing history with them. You just want to watch some videos. You don't necessarily want to share the history, right? So, how do we make it technically impossible to for a service provider to have such code executing, or or where basically the implementations depend on service provider adaptation. So YouTube would have to use this system, but how could YouTube provide their service to you in a way where you don't lose your digital sovereignty, but you get all the same features, right? So how do you stay in control of your access to data and in control of your data, but also keep all the same features you have right now? How do we make it in a way where YouTube doesn't gatekeep access to your data, but by just being your digital self, you have access to data, right? And YouTube doesn't. And YouTube only has access to data when your digital self specifically wants to provide that data to YouTube. So how do we make the service to respect a user's digital sovereignty? To achieve this, when the state of uncontrolled exposure gets loaded, a service provider has execution context. It, as with actor software or without it, it has access to offline storage. It has access to all kinds of uh, signals for a bunch of stuff, right? So how do we prevent that access, or that immediate access, but still keep all the same features? So there's no change in YouTube's user experience, but there's everything gets changed about how who controls your data. Right now, YouTube controls your data. So how do we get you, your digital self, controlling the data, right? The way to achieve this is by having, uh, well, let's start here, by having a private data space within the service boundary. So within the service provider's platform or context, there is a private data space that has control to or has capability to control resources. So in your private data space, you have the ability to view your history. You have the ability to write to the history, or you don't have to do it manually yourself, but the actor software can handle it uh, within certain constraints. And you also have the capability to control your digital identity. So if if let's say automation services are needed, how do you uh, how do you use an automation service without giving up your digital sovereignty, and how we prevent the service provider from becoming a data custodian is in your private data space. You have these two capabilities. Basically, the resources are just data related to the history. So if automation without presence needs to happen, like let's say there's an analysis job for your view history, and by doing that and returning the result to your front end, your instance of the YouTube UI, um, better content could be fetched and served and suggested to you in your private data space. How this would work is you would just in your private data space you would post a public identity. It's just a random identifier that's not really linkable in any sense. It's not backwards linkable. You just uh, post the identifier and public keys related to that identifier here. And then when you want to subscribe to an automation, you would um, use your resource control capability to select the history, or it would be handled by the actor software. You wouldn't have to do it, but you would have to once just consent to it, like, okay, I want to share my history to get better suggestions in my video feed, right? You just click it once, and then whenever you are on the platform, the automation jobs would get subscribed, but all that would be sent is the history defined in the contract, and then with your identity control capability, you would also insert the identifier in the automation payload and sign the whole payload with your private key and send it to the services. And then the services would read that identifier and get look up the identifier's public keys from the identity registry and verify that that this is the identity it claims to be, So verify the identifier and then do the job with the history, and then when you later there would be some interval or whatever in the front end, it would fetch a result, service result endpoints, and once again verify that it's you, and this way the automation result would go to the right place, and the service would then by contract remove all the data in there. And if the service gets audited, like someone would go and audit the service, if they can't prove that um, you subscribed automation by signing it with your private key, or the timestamp you set in the signature would be expired, then it would be proof that they have breached their data processing contract. So it would be cryptographically verifiable way to prove that what these guys are doing is against the contract. They're breaking the law. Like, it would just be mathematical proof. There would be no question about it, right? And then another uh, thing that happens here is these resources should be conflict free. They are like just any resource, any utility, right? It could be the history. It's a snapshot. It would be, it's probably an append only log uh, that just grows and nothing gets removed, or it could be just some like OR set, observed removal set, or observed removal map, right? Any conflict-free data type that can be merged and whatever, but with signatures. So if you want a collaborative editor that is just verified between two uh, pairs, right? It's just verified between my laptop and my phone. My phone verifies that it really is my laptop, or uh, an an identity in the identity registry that I have actually shared the resource access to. Then what would happen is when I want to make a change on my laptop to a resource, it would um, be signed by the private key, and possibly the resources could also have like role keys or capability keys, right? A key for that represents ownership, a key that represents manager capability, key that represents editor capability. And it could be one signature or two signatures, whatever the trust model is. But in any case, with conflict-free data types combined to cryptography, uh, this client here could verify that it really is this client, or it is an authorized client that made the edit, and it can also be displayed who it is and everything, without any need for this service other than that just the actor software handling all this. Uh, sends the information through the base station to this actor software that then verifies and merges the change. And this way, these resources are verifiably eventually consistent between all clients that share the same resource. One thing about, as I said, these are all encrypted here. So the, each resource would have its own set of credentials that are only known within this private data space. So if you create a resource, you create a it's like a, let's say you create a private YouTube video and you want to edit it on YouTube with your friend. You want to collaborate on making the description and all that stuff. You would then either share a link to your friend here. This is you and this is your friend. You want to collaborate, you share a link to a trusted channel or discover their public YouTube profile. And by discovering the public profile, you can access, you get access to their identifier or identity identifier, like however you want to say it, and you get access to their public keys. And with their public key, you could um, encrypt. You could create an embedder, symmetric key, encrypt it, wrap it with public key of your friend, and send it to your friend's inbox that has it. And the payload would then contain the resource credential, the private video credentials. And with those credentials, they can connect um, to the base station of that resource, and you can start communicating with end-to-end encryption and with conflict-free changes through the base station. Both of you also will have your own local state, and in the case you would want to remove your friend from having access to that resource, to your copy of the resource, you would then set them their access as revoked, and they would also get the information. This cannot be guaranteed, but uh, the, the state of their resource should also get wiped by the actor software once it gets the information that in the resource you share, this user's access has been removed. Um, it would be deleted completely from this instance, and it would not know how to find it anymore, or remember the keys at least. But what might happen is that they have already copied it or whatever. It's the same thing as with any other protocol, right? What can be guaranteed is they won't be making any changes in your version of the resource, and on YouTube platform they won't be seeing it, but they might still have some information of it left, and it cannot be prevented, because once you have shared something, they could just have a memory of it, right, or anything like in their own head. But it's like this, it's as secure as any other model, and more secure even. But how do we achieve all this then? How do we get to the point where we have a private data space within a service boundary. How do we get to the point where we have a private data space within YouTube? What we need is this phase right here. We need to have a way to have a device bound capability that the actor software can discover. The actor software can ask your device that, okay, what credentials does this device have related to this service boundary? And after credentials are discovered, these credentials are then used to discover the private data space credentials that unlock all the other credentials which allow you to control the resources and control your identity. So actor software on a device asks what capabilities this device has, uses those capabilities to fetch from offline storage or from a base station backup an encrypted resource and decrypts it with the capability on your client, and then through that process it finds another set of credentials, once again fetches it from offline storage or base station backup, and decrypts it, and using this credential it fetches your private data space root. So it fetches the root of your private data space, and in that root you have all the credentials associated with your private data space, so all the resource credentials and the credentials to control your identity, or how your like alias, public alias or identity, how others verify it's you. You have the ability to control how others verify it's you, right? And this is like the common, it's kind of like a login flow, but it's not reliant on the server or the service provider, because you can also find the state from your offline storage through exactly the same process. And how do we get here? We start by doing a device capability pairing, right? We form a pair between um, the service boundary and your device. We give certain hardware derived cryptographic access or material that is scoped to the specific service boundary, and that gets used to uh, that just gets saved, right? That just then it exists. Then there's the ability, after pairing, you have the ability to discover uh, a device capability. And once you have done the pairing, you will enroll the PDS credentials so you can later discover them. And what this means is that you start by doing the discovery phase. So the actor software has access to the credentials, or the device capability. It's pretty much the same thing, but so the actor software has access to the device capability, and it would then create an account. It's not really an account; it's just credentials to your private data space, but like you could think of it kind of like an account. So you generate a similar capability, a credential to access the private data space. You generate it. It would be an identifier, verifier, and like cipher key, right? And then you encrypt it with the device capability. You encrypt the private data space credential with your device capability you discovered. And then you or the actor software stores it to offline storage, and if network is available, it also backs up the resource to the space station that is completely blind to any semantic meaning. It just sees that some IP posted this random value, that, and the servers or service provider sees that this random value was stored, um, indexed by this other random value, right? It's just like opaque identifier and opaque bytes, ciphertext, and unique ID, right? And then you move on to the private data space, you start using the service, and next time you use it on your next session, you can again discover the credentials, uh, or discover the capability, and then discover the credential, and then gain access to your private data space, and it's not reliant on the service provider because it's all in the offline storage as well. Yeah. Then we have this third one, which is PDS credential recovery, which is pretty much just you once again you have enrolled. You can actually, like, before I move on to that recovery part, I will say that you can do this pairing with as many devices as you like, right? So there would be there's a way to like move your credentials from another device to another device. I can transfer this my PDS private data space credential to as many devices as I want without the service provider finding out what the uh, PDS credential is exactly. I could move it around to as many devices as I like, and all devices would then I would then pair all those devices. They would have a capability I can discover that I can use to discover and decrypt the PDS credential, and therefore access the same state on multiple devices without the service provider finding a single piece of information on that state, or not having any capability to read or do anything about that state, not change it, nothing, because your client authority decides whether to merge state, whether to accept a state or not, based on your like private keys. Based on you control the private keys, the service provider doesn't know about them, and the private keys you have, or rules, access rules you have, control the state completely. So You are the one in control. Your devices are the ones that control everything, not the service provider. Then, if we move on here to the credential recovery, here um, that there was already that we could have multiple devices, but what happens what happens when you broke all your devices, or or you just had it on one device and then was like didn't pair any other devices or only had one device that got broken. Like in any case, you lose all your device capabilities in one share. Like it doesn't matter how you lose them, you just lose your device capabilities. So with the credential recovery flow, I have been trying to think about how could just intellectual property give access back without it being like too complicated or too long thing to remember. Like you don't you don't uh, memorize a passphrase, or you maybe you don't actually want to print out a document and store it and remember where it is and everything, just to recover your account, or not your account, recover your private data space, your state, your identity. Um, so how do we achieve that? What I have been thinking initially, or so far, is we should probably use email here to just have an external verification that you control this email. You can verify that you control this certain value, and it can be also done in a way where it's like device bound. So if you start the flow on this device, this laptop, you log into your email account, get the number and everything, and then send it from this device to the server. We can like have this triangle triangular verification where it must be the same server, same email client, and same device that submits the value. Otherwise, uh, we cannot verify that it is really you. And once this process has been done, uh, your email would be hashed to a similar opaque identifier as everything else. So 256-bit value, and using that we would look up uh, just once again similar, like there's really no semantic difference, opaque blob, and serve it to the verified client. And now on your client you would have to submit uh, passwords, I guess. There would be an word or whatever value you initially set it as. It can be just like, it should be something you remember. It should be something you remember, and you submit that value you remember and another value you remember, and With those values, uh, we can once again decrypt the state, and actually you would submit the values prior to submitting the email. You would submit them just on your device, not to a server, just locally happening stuff before you submit the email to the server, because you would also, to keep things consistent, you would have to have a verifier that shows the server on top of you knowing the identifier, which is your email hash. And then you would have this other value only you know hash that is used to verify the connection or authenticate the connection. And then you would have the third value that is used to derive a crypto key that then gets used to unlock to decrypt the state. And you would have the BDS credential back. You would have your BDS identifier uh, uh, verifier and cipher key back. And then you would do device capability reestablishment on your new device, and that would just basically mean that you do the pairing, you do the discovery, or or you just do like this pairing and credential enrollment that starts by the discovery. And then you would just store jailbreak value to a base station and offline storage that can be discovered and decrypted with your new device capability. And through these flows, you are guaranteed you always get back to your private data space only you control. And always the device capability is always needed to um, access your private data space, and through your private data space you do selective disclosure. You only share the things you want. You have sovereignty over your data, over your identity. It's not the service provider that uh, owns your data, it's you that owns it. And the service provider just has to provide you an useful service. They can still make sure that your public identity has paid for their service and that kind of stuff, but it's still you are still the one in control. And even if they stop, they don't give you base station access or service access anymore, you still have your offline state. You can export to another service you'd like to use, or you could you couldn't perform this anymore because they deny all. Or you could actually, yeah, because of the way this is designed, it doesn't rely on the server here. Um, so you would want, like, you didn't pay and they did denial of service for you at that point, and now you want to move to another service provider. What you would do is, if it's compatible, like if they have this option to get data from this service provider, you could go here and press that you want to authorize an exchange of data, and then the service provider would make a cipher key, and then they would use these service providers. They still have access to fetch these service providers public key, wrap key. They wrap it, they send it there to this service. Wait a second. No, I still have to think about it, but I know it's possible to make this in a zero knowledge manner. Like here, service providers don't have to get access to any information. You would still have control over everything here, and you can do the authorized exchange like an OAuth protocol, or just export and import the data. And if we look at this, I just wanted to show that we can actually scale this. Is the usability of this is so bad. I'm pretty sure that's like a part of the group here, but it still doesn't work. Right, so you can scale this structure. You can move, you can scale this horizontally. You can add many service providers, and they can all do the authorized exchange between each other. You can share data. It's interoperable as long as this service provider decides to support this service provider schema. They do some kind of normalization, or you just export it and then you normalize it yourself manually and then import it to this service, because they should have the state import option if they're doing it the C-base way. And you can also scale up vertically, right? So here's one. This area represents a client, and this area represents another client, and you could have infinite amount of clients to this service provider. They can share resources between each other, uh, have real-time connection, encrypted connection via the base station. They can verify each other's identities and all that stuff. So infinite amount of clients per service provider and infinite amounts of providers uh, work with this protocol. Like it can uh, it can be done across the entire internet. It's not something that is only fits for one service. It's interoperable, right? And now, to demonstrate how this might work a bit, we can use this. I have actually registered already a credential here, so let's use or a capability to localhost with my libraries. So let's use CK credentials. We can use the discovery, and this would all be handled by the program, like for the average user. But a programmer would like do this stuff uh, in their program files, and then the average person doesn't have to write this stuff. It just happens automatically when you press a button or whatever. But we could have that, and this UI is really bad, but we can open this one. And iPhone or Android, I have to find my phone. I'm not sure which phone it was, but I think it was iPhone. So now I can use my passkey with Face ID. And there's the capability that was actually promised. So let's do await capability, so I won't have to deal with that again. And this isn't a real service, this is the local host, so I can actually expose my credential here. Also, like if you're a developer, you wouldn't globalize these APIs, and they won't be global in Cbase's actual SDK. This is just a really early demo and a playground for myself to try this stuff out. So I will then get these three items. I have the opaque identifier, I have the verifier, I verify connections using HAMAC or Cbase DOS will do. Can be done in other ways too. And then a cipher key to encrypt and decrypt the state. And I can't actually show any flow that much because I don't have a credential or this the hell it is. It's capability. Yeah, I don't have a no. I don't have a private data space credential registered or a private data space or I haven't enrolled a private data space in my local host. So whatever. But what I can do is I can have that capability, and then I can have a credential, and it can be from it can also be from there. I can do the generate credential, and now I will have here a different credential, right? So now I have two sets of these credentials. I mean, at, at the beginning, it's called a capability because it's a device's capability to uh, generate a credential, and it's only bound to that specific device's hardware. Like here, I'm using WebAuthn Navigator Credentials API to achieve this. And then this is just a basic crypto API that generates these from nothing, just randomness. random data, and this is deterministic data, that is device bound capability, right? But all credentials are the same, our resources look the same to the base station, to the server, to the network. Only capable clients, capable end user devices can actually view the state in a meaningful way, and only some devices can write to the state in a meaningful way within the service boundary. If you export it and edit it, it's a whole different thing, but I think you understand. So now that I have these two credentials, I can, let's take a goal to save this credential here, this private, this would be the private data space credential, and let's have a goal to save it to the offline storage encrypted, and then reload the page and try to get this credential back. So let's like remember this ID at least. Let's put it there to just save it, and have a let's do, let's just encrypt that thing there. So let's have a enc here and have C crypto, not constructor, want to crypto suite, and cipher encrypt. Also we need to have the weight, and let's have kappa. Let's have cipher JSON web key, and we also need the bytes from this thing here. And to get the bytes of this thing, we can just use G bytes, and we can take bytes from JSON like this. And now we can just put the credential there. Now if we console log this encryption thing here, yeah, we have a JSM result. Advanced encryption standard Gallois Gallois yeah, it's just a Gallois curve something, I don't remember what it stands for, but yeah, now we have encrypted the credential, and now what we can do next is I'm not even, like, I haven't updated the offline storage, so I'm not even sure if this works or this will be a fumble, but we can have offline storage put keep. We should have the capability ID as our key, then we should just have the encrypted thing as the value, because indexed DB access supports structured clones. It's like the best, most performant option here. Just store them as JavaScript objects, structured clones, right? And offline storage uses that under the hood, and like this. Also, even in its current version, which I haven't updated, that this like offline storage class should accept only an ID of this length, only with these characters. So it has a regex and type evaluation or validation, and only uh, uh, object as value. It only accepts an object with an IV and ciphertext, and the IV must be 12 long, unsigned integer, 8-bit long unsigned integer array. Right. So each of these is an 8-bit unsigned integer here. It's an array of unsigned 8-bit integers. Right. And array buffer that and its length must not be 0. So a non-empty array buffer, so an object like this, it gets validated. And yeah, it went through. We can take a look at it in the application. I think we have index.db, we have offtext.db here, and here we have it. We have the encrypted value here stored in the offline storage. We can reload, it's still there, and now we have nothing here. And we can once again get the credential. We have to discover it. Oh shit, my phone ran out of battery. That was surprisingly quick actually, but I have a thing here. It's, I'm happy I have it. So like in this is like a scenario you wouldn't want, but it's not a problem because I could still I could have already registered device capability for my laptop, right? So it's not like I'm forever reliant on. Okay, it's not gonna happen. This sucks actually. I just I think I will continue later. Let's see. Okay, so it had some kind of slow loading even, and I don't know if I have even time to get this with the amount of battery this thing has. It's pretty much nothing. But here, let's try and please get it, or I'll have to wait a million hours once again. We do that, and now we should have the credential there, and I actually recorded it with OBS. Right, that's good. So let's try it. Console cred. I don't know why I saved it as cred, but whatever. Yeah, I have it. And this is the credential we have stored. And now to find it as an application, we could obviously manually find it there. But as an application, right, we let's just use BDS cred because I already misused the name there. Flash storage get. We just want to get cred ID and console log BDS cred, Now we got it here, or we have the uh, ciphertext or blob or envelope or HGSM payload or whatever you want to call it, and then we do the decryption here. So await decrypt to shoot cipher decrypt. I hope I used the capabilities cipher JVK and not the actual credentials, then I would be locked out. I don't fucking remember anymore whether I did it right or not. But here we have, yeah, we need the bytes first before we transform it. So we just place the artifact, or yeah, it has many names. Let's call it artifact for now. So now we have decrypted it. We can console log it as it should be just an array of numbers, right? Yeah, and then when we want to turn it to an object, we just use C bytes, and these are also in free shakeable format and convenience classes and all kinds of stuff. But yeah, we could just have from JSON here, and from the decrypted bytes and console log object here, and we should have apparently we did a little. Oh yeah, yeah. Okay, let's just have it change. I just used a completely wrong method. I was supposed to use to JSON. We are turning bytes to JSON, not getting bytes from JSON. I don't know what the fuck was that. So here, don't leave me. Yeah, it worked right. And here's the initial value. So we could just console log. I think this should work, and this should return true. Right, so we got the credential, and you could do this programmatically, click, yeah, whatever. Uh, and like this was offline, but you can also do it in the cloud. And also, as long as the website gets served when you are not connected to a network. So if there's a service worker that has cached, or there's just a service worker that's capable of serving your application, which will also be in the C-base libraries. There will be a bundler that just produces a distribution from your like basic SPA, your basic single page app using any framework you like. It just converts it or adds a service worker and stuff to your distribution. So it's like it will be pretty much just something you won't even notice it's there, and you will have offline capability. You load your website once and you can like go offline. That's it. And like all the state will be stored offline as well as online, so you can uh, yeah, like just what I've shown here. We have the offline storage, space stations and stuff. This is what I have been able to actually code so far, that I have been able to code in a way that is actually maintainable. There's a couple issues even with the crypto suite and uh, zero knowledge credentials. I, I, I asked like the actual web Autumn developers, uh, the ones that are like writing the actual specification for WebAuthn, that is it okay to use WebAuthn for this, and that is it. Like any other remarks, and a guy named Emil from Ubigo gave me like a bunch of great tips that I will try to implement. Some of them I like kind of disagree with, and I will like do my first fix and maybe ask him again to see if we agree once I give my reasons for doing things a certain way. But like even with the way things are now, they're not the optimal, like the very best way, but like it should be okay, and it should be like supported in the future to use like this of to use WebAuthn API just offline, not for identity, just to get credentials and recursively or gradually discover your private data space, and then you control stuff. You control your data. You own your data. You are sovereign digital uh, entity. You control everything you create, everything you write. It's only in the actor software memory, and then whenever it's stored, whenever it's transported, it's encrypted, it's gated cryptographically. It's like you control all your data and you lose no features whatsoever. So there's just absolutely no, like the latency just doesn't exist. Like even with dual signatures on merge in a real-time application, you don't like even notice it. It's like it's not a reason. There's no reason not to give you digital sovereignty for real. It's like there's nothing astronomical about this. This is web APIs that are accessible to absolutely every single company, developer. Like everyone can do this using the technology available to anyone. And I will make everything open source as well. So like you can actually, once Cbase is ready, you can actually start demanding uh, the service providers to give you your sovereignty back, because like this will show that it's possible to do with with like no there isn't a single like, oh, you shouldn't do it because of like they will lose this and this, like you will keep everything. Like you could have YouTube just the way it is right now, but with more control over like your digital self. Like you could have all the applications you have right now without giving your digital self away to the companies to monetize you as their product, right? Yeah. Anyway, if you're interested more, if you actually watch this awkward ass video of me like just yapping about stuff I haven't even completed yet, and I'm just kind of uh, working to get everything in place myself and have like representable materials. And this is kind of a training run for speaking about this topic, right? Even and yeah, but there's like links in the description for the GitHub organization, and you could just pretty much go from there. But I think I'll include an npm link as well, and maybe some link. Maybe I'll add a LinkedIn link as well, so we can connect if this is a topic uh, you are interested in. If you want to do sovereign applications, did like or like I have this term called digital sovereignty enabling, right? If you want to do services and applications in a digital sovereignty enabling way, where you respect your users, you respect their privacy, you respect their control, um, then we can connect on LinkedIn and see where things evolve, right? But yeah, thank you if you actually watch this to the end, and like, this will pretty much just revolutionize everything. Like if people just want this, which everybody I have spoken with so far seems to want, mm, then like yeah, once this gets adopted, uh, like you have control over your digital self, and like when we like lately there has been discussion over like a EU depending on United States for bunch of stuff. So even with that, even in that aspect, it's like this solves that too. Like we can still, as like if we are like I for example, I am developing um, uh, enterprise resource planning tool, entrepreneurship platform. Uh, like they are same thing kind of like there's a like this social platform and other features, and the whole like online thing, it's all accessible through the web, it's open and all that stuff. So it's like a platform, but it also has all those like enterprise resource planning tools. We'll have them, and like we want to utilize like Cloudflare's architecture, for example, and they utilize like Google Cloud and this and that and this. So there will be data in multiple servers replicated and all the stuff. So once we have it encrypted and everything is done in a way like that actually only the user can have access to it, um, the infrastructure will just be useful, but it will be useful, but it won't like have any. It will be basically blind. It cannot see your information because it's all encrypted, and it's like meaningless. It's just random identifiers, random data. Like you can't link them. There's no keywords that help you profile stuff. Like you could. The only thing that exists is just like the length, like how long is this. So you could like basically identify credentials, but there we can add some kind of randomness to each credential, right? We could have just this random length of values, additional values that like mix things up a little bit. But yeah, um, this is what I'm working on, and yeah, I guess there's nothing else.